Hello everyone. This is the final term project for DSE 598 Statistics for Data Analytics. The dataset provided to us is School Find Report, for which the model has been built. We are a team of 4. I'm Charunetra, Shravani, Uday and Yogitha are my teammates. Now I'll start with the presentation. The dataset mainly focuses on fines imposed on educational institutions in the US. The given dataset has 10 sheets covering 10 years from 2010 to 2019. This dataset, from this we can derive insights that will help institutions in improving the policy and transparency in schools. Next slide. Coming to similar datasets and analysis, in descriptive analysis, variations in schools, regions, and fiscal years are examined for insights into the education sector. Regression-based approach is generally used to forecast future fine amounts based on historical data, which will be used for predictive modeling. Through data mining, recurring factors leading to fines are identified, which helps in enabling proactive regularity strategy. Next slide, please. The dataset has 8 attributes, which includes the fine types and imposed fine amount. There are 6 fine types. Crime disclosure comes under the CLERI fines. Schools providing false claims comes under QUITAM. IPEDS fines are nothing but schools that provide inaccurate data. Regularity breaches comes under other violations. This picture showcases the total fines imposed every year from 2010 to 2019. Next slide, please. EDA is very important for uncovering patterns and generating hypotheses, providing a foundational understanding in decision making. We have analyzed the time series trends to years. Among all fines, CLERI and IPEDS are highly imposed, and the rest are combined and showed in this picture. Now, I will hand over this to Yogita to take over the next slides.
So our next data analysis is based on referral reason. The sum of fines imposed is depicted demographically on the left side for each year starting from 2010 as the inner circle, extending up to 2019, that is the outer circle. As we can see, most of the fines imposed in the initial years are due to QTAM, and later the fines imposed category is gradually changing to fraud and campus security. These are the recent issues we are facing in the educational environments. The next category analysis done was based on school types. As we already know, we have 3 different school types, that is public, private, and preparatory based schools. For each school type, the sum of imposed fines is plotted as a bar graph, and a table for how the fines are being imposed for each year is also shown here below. From the graphs, we can understand that the schools in preparatory have been imposed highest fines in every year and need basic rules for better functionality. Our next analysis was based on geographical analysis, and the graphs depict that the Pennsylvania state has the highest fines imposed at about $91 million, accounting for 54.83%, and Utah state comes last in line. By count, that is the left graph, states that California is recorded to have highest number of schools being charged for fine, but the imposed fines are considerably low when compared to Pennsylvania state. And the last analysis is done was plotting a correlation heat map that represents the relationship between imposed fine amounts, school types, state, and OPE ID, that is the school unique ID. To understand the correlation map, the correlation strength comes into play. The positive values closer to 1 indicates a strong positive correlation, and the variables are proportional to each other. Whereas a negative value closer to -1 indicates a negative correlation, indicating inverse proportionality. In our graph, a lot of correlation strengths fall in the category of -0.5 to 1, that is shown in the right side line graph, indicating that there are good dependencies over each other, and this is a good sign that we can forecast the fines being imposed for future years too. This is nothing but predictive modeling that Charu has introduced to us in the third slide. After our exploratory data analysis part, we have worked on hypotheses that will lead to our model. Our first hypothesis was detecting any anomalies in our dataset. Our purpose was to identify unusual data points in imposed fine amounts, as this attribute is the foundation for our project. Schools with anomalies are marked to be deviating from the data points norm, portraying irregularities. The scatter plot shown here presents both normal and anomaly data points. Universities named University of Phoenix and the Art Institute of Pittsburgh are highly deviating from our datasets. These anomalies are not considered as outliers in our building model, but this implies that these specific schools need special attention in terms of regular monitoring. That is it with the first hypothesis, and I will hand over to Shravani for the next hypothesis.
Yeah, the next hypothesis that we're going to talk about is the correlation analysis and hypothesis testing. So, which will explore the correlation between our main feature, which is the imposed fine amount, against the school types. We can observe that our data contains three different school types, which is public, private, and preparatory. And we are trying to see if there is any significant differences in the mean values among these different school types. As a result, we found out that the correlation between these two columns is a value of 0.01 with a p-value of 0.84. And the ANOVA statistic is giving us a value of 0.89 with a p-value of 0.416. This clearly indicates that there is a very weak correlation between the fine amounts and school types, and that school type has nothing to do with the fine amounts. We've also done the pairwise comparisons, taking groups like preparatory versus private, preparatory versus public, or public versus private, and the respective mean values, lower and upper values are also printed here. The next hypothesis that we're going to talk about is the time series analysis, which will help us aggregate the fine amounts over the entire duration from 2010 to 2019, so that we can understand temporal patterns or behaviors in this data. As part of this analysis, we have found out that the year 2010 and the year 2016 have a peak value, which is in accordance with the data characteristics that Charu had mentioned. So as part of this hypothesis, we can understand why 2010 and 2006 have those peaks, which schools have been responsible, was there any special event that needs to be taken account when we talk about these schools. As a result of all these hypotheses, we will be building a model. So the model will work on the data mining task called clustering, so that the objective will be to uncover patterns on our main feature, which is imposed fine amount amongst the different data types that we have. Different techniques like k-means, agglomerative, and devious scan can be used. So the insights that we are going to use for our model come from our hypothesis. For example, from the anomaly detection, we can identify the states. From the hypothesis testing and correlation analysis, we can find out the correlation between the different features. And also the temporal analysis will give us how the features have varied over the years that the data has been collected. With all these insights in hand, we will be able to build a model which has the following impacts. It will be helpful in taking informed decisions. We can guide our resources based on which schools we need to focus on. For example, if any school has got a fine and it has become compliant over the years, then we can understand that the school has improved and it has not exceeded any regulations. And also we can do anomaly identification, where we can flag these exceptional cases. So in the end, we will have a model which will be efficient to discover the patterns in the data and help us in taking informed decisions. Clustering is the data mining task that is going to aid us in building this model. Now I am handing over it to Uday to continue.
Now I would like to discuss each technique and the results. For our first algorithm, we utilized k-means clustering without predefining clusters. The algorithm decides the optimal number of clusters on its own. We can see the results via the scatter plot showing imposed fine amount across states, assigning different colors to represent distinct clusters based on similarities. This technique groups states with similar fine amounts together, thus getting 8 different clusters. Moving to the next method, our application of agglomerative clustering with 6 specified clusters uncovered a similar process of grouping imposed fine amounts across various states. The resulting scatter plot illustrates the distinctive clusters generated by agglomerative clustering, showcasing patterns that resemble those observed through the k-means algorithm. This alignment in clustering outcomes between the two methodologies suggests a parallelism in the identified groupings, reinforcing the consistency and reliability of the segmentation methodology across different clustering techniques. In the next method, we use the dbScan clustering technique. Unlike k-means and agglomerative, dbScan identifies clusters based on data density and not predefining cluster counts. This plot eliminates regions of dense imposed fine amount across states, revealing different patterns. We can observe that dbScan has formed 16 clusters for the data. While comparing the three models, the different clusters count highlights the diverse perspectives and patterns each algorithm uncovers within the dataset. The choice of the optimal number of clusters depend on the specific characteristics of the requirements and the objective of one's analysis. While talking about the relevance to the stakeholder, our findings offer a granular understanding of compliance trends, pinpointing specific risk factors and areas needing attention within educational institutions. For regulatory bodies, these insights provide a nuanced view of compliance behaviors, enabling the formulation of targeted and effective policies to address identified gaps. Additionally, our research contributes highly to the academic sphere, enriching the discourse of regulatory dynamics in post secondary education and offering empirical insights for further scholarly exploration and analysis. In conclusion, combining these different clustering methods doesn't just make our approach unique, it also helps us see compliance in many different ways. These methods show us various patterns in how schools follow rules and pay fines, giving us a better understanding of the small differences between schools. This bigger picture helps people in charge make better rules and save money in schools. And with that, we wrap up our presentation. Thank you.